do is just put, like, hit the pause button here. There, pause button. Like that. Pause. We're going to come back to this, all right? Because what we're about to do, I need to first convince you can be done. And you saw it in pre-cal, but pre-cal was a while ago. So let's take something very simple. I think I'll keep that right there. Let's take something very simple. If I told you 2 over x plus 3 over x minus 1, yeah, that's good enough. If I asked you to add those, how would you do it? Get a common denominator, right? So you'd multiply this one on the top and bottom by what? X minus 1. You'd multiply this one over here by what? X. And so you would get something like what? 2x minus 2. That's up there, right? Over here you get plus 3x. And you put the two denominators together and you get this, right? And so it would be, what, 5x minus 2 over x times x minus 1? Yeah? Okay, so what we have here is an expression with how many distinct linear factors? 2. And there is a way to go from here back to up to this, right? Right? I mean, it's pretty trivial going from here to here. That's a basic college algebra skill, adding two things together. Going backwards is what in pre-calculus they call partial fraction decomposition. Do y'all remember that? Going from here back up to here. And so what the whole concept of partial fraction decomposition hopefully taught you, and you've forgotten, I know that, that's okay, is that if you have two distinct linear factors, you know that this is going to go back to each distinct linear factor and a number on top of each one. That somehow this turns into this, right? Yeah? Okay, so what we do at this point, back here, unpause, play. Here, hold on. Ready? Play. All right, so we're back to this. I know because I have three distinct linear factors that there is some way that I can rewrite this entire expression where I have a number over this plus a number over this plus a number over this. There's a way of doing it, and I have to figure out what those numbers are. All right, so this is where I kind of walk away from the integral. I'm not pausing because I'm still part of the problem here. I'm not ready to integrate yet. I have to do the partial fraction decomposition. So this step is what we call partial fraction decomposition. And so what you do is you rewrite the integrand the way it appears. There it is. That's what I'm trying to rewrite. And so I know from my experience with partial fraction decomposition in pre-cal that I'm going to have each linear factor is going to appear in my answer when I split it all apart, right? If I'm able to decompose this fraction into its parts, partial fraction decomposition, then this should be a number which I don't know right now. And this should be a number which I don't know right now. And this should be a number which I don't know right now, which I'm going to call capital A, capital B, and capital C. Show of hands, how many of you this rings a bell? I mean, like, you remember seeing this at some point? You may have, your instructor may have used, instead of A, B, C, A1, A2, A3. Anyone's instructor use A1, A2, A3? Okay, sometimes we use that because, well, what if you had 400 linear factors? Then you couldn't do A, B, C, D because you'd run out of letters, right? But you could do subscripts and you'd never run out of subscripts. That's why we use subscripts in math all the time, because we never run out of them. But for this class, A, B, and C are going to work. The highest we'll ever go is E, maybe F. So we might have A, B, C, D, E, F to figure out. But okay. Y'all doing all right? Y'all seem a little, what's wrong?
It's like a horror monster that you thought you killed a long time ago.
Well, didn't you want to know back then why you did this? No? Oh, okay. Well, hold on. Let's talk about this because it's worth it. Look. If you can integrate this, if you're trying to integrate this, which is what we're trying to do, and that looks like a disaster, why would we prefer to integrate this? Yeah, and that's a number, right? Pop it out. That's a natural log. Natural log x is the antiderivative of this. The antiderivative of this is 1/2 natural log of 2x minus 1. And the antiderivative of this is natural log of x plus 2. And we're done. If we can just figure out what a, b, and c are, we're done. That's why the partial fraction decomposition is important to us. Because it makes this terrible thing, this monster, become that. But that's so much easier to deal with than that is. All right, so how do we do it? How do we do the partial fraction?
You take each one of them times the denominator and the other.
That is correct. You take the denominator right here, this, and you multiply that denominator on the left side and the right side of this equation. So imagine taking this entire thing. I'm going to go off camera here a little bit. Well, I'll try to squeeze it in here. I'm taking this thing and I'm multiplying it on the left side, and then I'm multiplying it over here on the right side. That's our common denominator. Now, what happens on the left side? The denominator and this thing cancel, and all I'm left with is the numerator, right? This cancels with this, and I'm left with x squared plus 2x minus 1 equals. Now, when you multiply this on this side, doesn't that have to distribute through to each one of the three terms here? Right? Each one. So it's really like this. There, then there, then there.
Oh, and then they're cancel off.
Okay, so let's go around the room. We haven't done this yet. So we'll start out here with Zach's table. Anyone at Zach's table, when I multiply a over x times this, what's left? What's still there? Or what goes away?
The x's go away.
The x, this x and this x will go away. I'll be left with
The
A,
two things in there.
and then the two things in parentheses. 2x minus 1, and then x plus 2. Okay, good. Moving around. Next table.
The 2x minus 1 will go away.
And so what's still there?
X times x plus 2.
X times x plus 2 and the b, right? So the b is on top. This 2x minus 1 cancels out with that one, and you're left with this, this, and the b. If it makes you feel better, just take this expression and write it here, here, and here, and then cancel out the things that go away. All right, back table. What's left here on my last piece? C? Did you say let's see? I heard you say let's see.
We got x
Uh-huh.
and the 2x minus 1.
There you go. Okay. So there the x plus 2 cancels. And that's it. All right. What is it we're trying to do again? Remind me, what is it we're trying to figure out here? What's A, B, and C, right? At this step right here, there's normally two approaches to getting A, B, and C. There's a short way that doesn't always work, and there's a long way that always works. So I'm going to show you the short way because you always want to try the short way first if possible. And then, as I move through more examples, of which we won't get to all of them today, you'll see that there's some that we will not be able to do the shortcut with. Right? So here's the short method to try and get A, B, and C. We first say, let's go for A. All right? Let's try and get A right now. This is going to be like the master equation that I'm going to work with for the rest of the problem until I get back to the integral. That part right there. All right, let's try and find a. So I'm going for a right now, okay? I'm going to go for a, trying to get it. Well, if I want a, it sure would be nice if this piece of junk and this piece of junk wasn't here, right? Like these two, if they weren't there, it would make this a less complicated problem, wouldn't it? So how can I kill this term off and this term off without killing this term off if I have control over x? If I can control what x is, what can I let x be that would kill this, but not this, if x was 0? So do you see that this has the factor x in it, this has the factor x in it, this one does not have the factor x in it. So if I let x be 0, this whole thing's gone, this whole thing's gone. Yes? So this is kind of where you can get a little bit of, this is one of the few times in math where you have control. And you can actually let something be whatever it is you want it to be. So I'm going to sit here and say, let x be 0. I always want to do that and just have this kind of like, let x be 0. Like, let it be. Make it so. There it is. X is 0. Rewrite the equation, the entire equation, rewrite it with x replaced with 0. Every x you see. 0, 0, -1, right? So I get -1. So when I let x be 0, the equation becomes -1 on the left side equals a times, what's 2 times 0? 0 minus 1, -1. Okay, 0 plus 2, 2, and then plus, I already know what happens to these, right? These are gone. These are history. So this just turns into -1 equals -2a, which means a is what? 1/2. That wasn't so bad. We know what a is. Questions? How do we get b? Same way. Going for b. How am I going to get b? So we start everything over. You look at the b term. You want to kill the a and the c term off. So you look for the factor they have in common. This 2x minus 1, right? You want to make that 0? So how do you make this? How do you make that one 0? You said it already. That's right. You just ask yourself, how do I make that 0? And then you solve that equation. X is 1/2. If x is 1/2, then I know that that's 0, right? That's what I'm doing. Understand? So let x be 1/2. X is 1/2. Now this is going to be a little more complicated because 0 is always easy to plug in, isn't it? This one's going to be a little bit more difficult. So what's 1/2 squared? 1/4. 2 times 1/2. 1 minus 1. That's going to go away, but that's the left side. Agreed? All right. Good news about this one. It's gone, right? This is gone. You plug a 1/2 right in here, that's 0. Who cares what everything else is? But it doesn't kill this off, which is what I wanted. So b times 1/2. What's 1/2 plus 2? 5/2. And then what about the 1/2 in here? It's gone. Y'all still with me or not? Now I'm going to say something. I'm going to turn this off. Where are we? Right here? And what the heck is that? B is what? 1/5. All right, 2/3 of the way there. How do we get C? If we're going to go get C, let x be -2. Because this factor and this factor appear here, but don't appear here, or doesn't appear here, so I can let x be -2. And let's see, what does the left side turn into? -1. And then the right side, everything's gone except for this, and I plug -2 in here, I get -2, 10c. Anyone get 10c? -2, let's see, 2 times -2 is -4, minus 1 is -5, times -2 is 10. So you should get 10c here. Yes, or? Okay. And that means c is what? -1/10. Yes. We're there. We have A, B, and C. Are there any questions on this? May I erase? Yeah? You erase yet, or? The original integral. I'm ready to go back to it now. I've done my sneaky stuff with my whole God complex thing. And now I've got a new integral. And it's actually 3 separate fractions. It was a over the first distinct linear factor, which I recall was x. I don't remember much more than that. I think the next one was the 2x minus 1, and I think the last one was x plus 2. Were those the 3 factors? Did I have a on top of x, b on top of this one, and c on top of this one? You have to get everything back in the right place. You can't just, just slap them wherever I want. So the original integral was rewritten this way. A for us, we turned out to be, what is it, 1/2? I just say put it up here, 1/2. Okay, fine. B was what? 1/5? And C was -1/10. That's the original integral rewritten with partial fraction decomposition. Now this 1/2, when I do my integration, this 1/2 can come out because it's a constant, right? The antiderivative of 1 over x is natural log of x. So I'm ready for antiderivative now. 1/2 came out, natural log absolute value of x. This 1/5 will come out, plus 1/5. What is the antiderivative of this? And you have to be careful here. 1/2 natural log of 2x minus 1. This is a 5. Let me fix that. So I hope everyone understands. The 1/5 just comes out from here, but the 1/2 comes from the fact that you had an a in front of the x, and you have to scale by that. Because when you take the derivative of this, chain rule would pop a 2 out, right? When you take derivative inside, and you'd have to get rid of that 2. And then the last one, minus 1/10, what? Natural log, absolute value, x plus 2, whoa, plus c, done. Except you could put those together, that's 1/10. How you feeling? Think maybe we've got about 15, 16, 17 or so minutes. We might be able to get this next one. I think I have 2 days on our schedule for this section. Pretty sure I do. Which reminds me, I'll pass around the sign-in sheet. Kind of gotten really bad about this. Last time I said I would take attendance off the quiz, which I haven't looked at, so for now, sign in, please. How are y'all feeling? Tell me, come on. Feedback. What's your story? Hungry. I know Zach's tired. How's your brain doing? You blew up already?
At least now I know what the purpose of all that stuff is. Never doing it the long way.
Uh-huh.
These comes, this, and that.
Where you multiplied it all through? Yeah, we're going to have to do that eventually. But what we still don't know, okay? I mean, what I've shown you right here today is that partial fraction decomposition is useful for us being able to integrate rational functions. What you still don't know is why in the hell do we want to integrate anything to begin with, right? Which is where we're going after this. But the way that we have it laid out at this school is that we do all the techniques of integration first. That way everyone becomes good at integrating. And then we go to the applications. I'm not sure if that's the best way to do it, but that's the way we do it. Shall we do C? Did anyone watch the video of me doing the homework assignment where I'm doing the homework problems in that room and then like the room next to me, they're watching movies and eating popcorn and no? I made a comment while I was doing the solution. I'm sitting there, I'm like working through this integral and I can hear them in the room next to me like watching some movie and they're all laughing and I see them walk out and they're all drinking sodas and have bags of popcorn and I'm sitting there like, what are they doing? What is this? Right? We're supposed to be suffering here. We're not supposed to be having fun. Is this a rational function? Unfortunately. Is the degree of the numerator bigger than or equal to the denominator? Yes, which means I must start with long division. So long division is going to start the whole thing off. Dun, 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 dun. Make sure I have that written out correctly. Yeah, I might need a little bit bigger here. Okay, x to the fourth. I need a little spacer here, right, for the x cubed term? Because I don't have one in the original problem, in the original numerator. That's my numerator. And then x cubed minus x squared minus x plus 1 goes out here. If you're missing like x's in here, like if you were missing something in here, you do not have to put spaces in the one out here. It's more for in here for keeping things lined up. Well, what do you multiply x cubed by to get x to the fourth? Just x? And then you have to multiply x times all these. Boom, 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 boom. So x to the fourth. Then minus x cubed, then minus x squared, then plus x. Nobody has a problem with that? Everyone's comfortable with what I just did? Now, change sign. What happens when you add down? What do you have here still? X cubed minus x squared. There's only one of them, right? Because it's negative 2 and then plus 1. Plus 3x. And bring this 1 down, plus 1. Be done? Nope. Get to go one more time. I can multiply it by what? 1. So plus 1 here. Multiply everything over there by 1, and it's just the same thing underneath. But then, change signs, don't forget that. Minus, plus, plus, minus. What's left? 4x, that's it? And we cannot turn x cubed into 4x, so we're ready for our remainder. Plus the remainder over the divisor, which is everything here, right? I'm gonna run out of room here, but I think everyone understands what goes there. If that goes off camera. No, I think it's squeezed on there. All right. $10 minutes. The original integral can be rewritten with that as the integrand instead, which is what I'm about to do. Integral x plus 1. Boy, I like that. And then plus 4x over x cubed minus x squared minus x plus 1. I don't like that, though. That's the original problem rewritten. You can handle that, right? The first two, no problems. So I know this turns into 1/2 x squared, that's your antiderivative, plus x, that's the antiderivative here, plus 4, I'll bring the 4 out, x over x cubed minus x squared minus x plus 1 dx. So what I did there is I just took care of the two pieces of this that I could take care of. And that leaves me with this integral. Well, that doesn't look like it's something obvious. It's a rational function. It's not any of the problems that I, like before we started, I said, we're going to do these. We'll start partial fractions after we do these. So it's none of those, right? It's a linear expression over a cubic expression. If it was quadratic, it would be different. We might be able to handle it, but can't.
You can't just like take an x out of the. Just put it-
Not out of everything. But
But since it's plus, yeah.
what?
Just out of the first three terms, take an x out of that and then plus 1 at the end. Would that work?
Well, but the x couldn't come all the way out and cancel. Because you're only allowed, I don't know if that's what you're suggesting, but you pull an x out of just these three, you can't cancel it with that x, because it has to come out of every single one of these for that to.
I was just saying, like, as a placeholder, so you can handle what's in the middle. I don't know. That was my best guess.
Well, what did we do in the last problem when we didn't have to do long division in the last problem, right? And I said that the second step, long division is the first step, the second step would be try and factor. This does factor, but how many terms? 4 terms. What's usually the thing that we try to use for factoring 4 terms? Grouping. That's called grouping, yep. Factoring by grouping. So let's take a look at that denominator. X cubed minus x squared minus x plus 1. We split it down the middle, right there. And we look at the first 2 terms, and what can we factor out of the first 2 terms? X squared. And then what we have left is x minus 1. So if we distribute x squared through to these 2, we get back those 2, right there. Now over here, we need to factor something out of here so that we get the same thing in a parentheses over here. So we have to factor a negative 1 out. So that gives us a what? X minus 1 here? And then when we do this, rewrite this, it's x minus 1 times x squared minus 1, isn't it? They both have an x minus 1 on them, right? So we pull the x minus 1 out, that's here, and then you're left with just the coefficients, the things that were in front. Can I change that at all? Anyone recognize that? That's x minus 1, then this is x plus 1 times x minus 1. Yeah? Difference of squares? And then I have two factors of x minus 1, don't I? So I can write that as x minus 1 squared times x plus 1. So I'm going to rewrite this integral because I'm down to the last 5 minutes. All right. Can we please remember that this right here was all sitting there? I'm just working on this integral right now. All right. So this integral can be rewritten x over these three factors, right? But two of them are the same. So I'm going to write x plus 1 times x minus 1 squared dx. Y'all still there? I know we've been going at this for like almost 100 minutes straight, but just see if we can at least get to the next step. U sub probably won't work here, only because one on the bottom is x plus 1, the other one's x minus 1. But the last problem, we had distinct linear factors, didn't we? Do we have distinct linear factors here? Well, x plus 1 is a distinct linear factor, isn't it? X minus 1 is different than x plus 1. It's a linear factor, but it's squared, isn't it? So what we do, we call this a repeated linear factor. It's a linear factor, but it's repeated. All right? Distinct linear factor, repeated linear factor. So how is it that I'm going to rewrite this? So how is it that I go and do the partial fraction decomposition? What did we say we did? For every distinct linear factor, I put something over that linear factor, right? So like for the x plus 1, I should put what out here? A over x plus 1. Now, would it make sense to you that I should now do a b over x minus 1? Yeah? But see, the fact that it's a repeated linear factor means this is not enough for us to do that. What we have to do is add one more thing to it. Another number over the distinct, the repeated linear factor squared. So let me explain this. For every linear factor, you have to put some number, which we're going to have to figure out, over that linear factor. For every different linear factor, you have to do that. If the linear factor is repeated, like in this case squared, you also have to do a number over that factor squared. What if this was cubed? Or even better, what if this was to the, instead of square, what if this was to the fourth power instead? I would have to do another one and another one, this time to the fourth power. So notice how the power starts off, it's x minus 1 to the first, then to the second, then to the third, then to the fourth. Each one of those you would need in the problem. But because it's only squared, I only need it to appear twice. Everyone understand? I don't think I'm going to make it. I have 2 minutes. What did we do last time at this point? Multiplied by this. Okay, on both sides. So what happens when I multiply this on this side? Goes away and I'm left with what? X. What happens when I multiply this whole thing right here? What's the only thing that cancels when I put this right here? The x plus 1 cancels, so I'm still left with what? The a, and then the x minus 1 you said squared, right? Good. Now here, the next one plus, I know the b is going to be here. X minus 1 is one of the factors, right? I have two of them in my common denominator. So the x plus 1 is still there, and one of the x minus 1s is still there. So it's x plus 1 times x minus 1. What about this common denominator right here? The x minus 1 squareds cancel, so I'm still left with the c and x plus 1. The goal of the problem is to figure out what a, b, and c are. Can you get a? How are you going to get a? Let x be -1. Right? Let x be -1. So I'm going to move faster through this because we're almost out of time. Let x be -1. And you get what here? -1 equals -1 minus 1 is -2 squared. 4, so 4a. And what about these two? They're gone. So a is what? -1/4? Can you get b? Uh-oh. Uh-oh. How do we get b? We have to kill off a and c, don't we? You can't kill off a unless you let x be 1, right? That's the only way you're going to kill a off? But if you let x be 1, you're going to kill off b. Aren't you? So let's try and get c. Can we get c? How can I get c? By letting x be what? 1? Let x be 1. And if x is 1, we get 1 equals, gone, what, 2c? So c is a half. But how are you going to get b? Where? You want to replace a right here with -1/4? And then you want to replace c here with 1/2, and then what? Plug in a number for x. So let's try and pick an x value that's not that bad right now. How about something like 2? You want to try 2? Let x be 2. Now I know it's not going to kill anything off, but the left side of this is what? 2. And then right here, 2 minus 1 is 1. 1 squared is 1. But then times a. What's a? -1/4. So this will be -1/4. OK, we plug 2 in here. We get what? 3. So careful. 3 times 1. That's 3. Times b? Yes? 3b? All right, so plus 3b. And then plug in 2 into this, and you get 2 plus 1 is 3. But what was c? This was half, so we get plus half times 3, so 3 halves. And we should be able to get b from that, right? What is it? What's -1/4 and 3 halves? 5/4? 5/4. So we have 5/4 plus 3b equals 2. Let's subtract 5/4 from both sides. We get 3/4 equals 3b, which means b is 1/4. I'm just adding fractions. I know it might take a little longer to do, but we have a, b, and c. And now we should be able to handle the rest. But I'm over on time, so maybe you can finish that one off and we can check your answer when you come back. I won't grade you on it. You can probably start doing the exercises here. At least you should at least try and do like 7 through 12 all. Page 334. I've done the odds. I've done the odds for this all the way up to number 31, and those are posted online. But that's what you should have at least tried for next class. It's the beginning of the assignment. Next class, we'll finish this up and start talking about whatever's next. Where's the sign-in sheet? Right here? Let me see it. Make sure you sign in. Sorry that was 100 minutes of just me talking the whole time, not asking y'all much of anything, but